Hello everybody. Welcome to this 3D Experience World Session 2021. Okay, myself, I am Rajesh Celestine, working as an application engineer for Atmata in Dubai. I have a vast experience of over 25 years. I have worked on various projects with various customers in design, as well as I have a combination of experience as well as an application engineer. So, usually speaking about today's design challenges. But let me tell you first, this session is today's session is for you, especially the design challenges what we face as designers. So, every idea starts from a sketch. So, usually when you try to, when you plan to introduce a new product, usually we start from a sketch. The concept starts from a sketch, and then they have moved to the parametric modeling. So, we do our modeling. And we do validate our designs, and then we produce our products. So we manufacture our products. Okay, so in today's session, what we are going to see here is I have done a design of a vacuum cleaner with 3D on the 3DEXPERIENCE platform. So with the 3DEXPERIENCE platform, it's a seamless and integrated workflow. From your concept design, so we start with the concept design with sketching. And then I have worked with SolidWorks, and then we will see how we are going to work with creating organic shapes. That is, most of our products require stylus. So we will see how we are going to create organic shapes, validate our products, create a proper design intent 3D parametric modeling, and we will add some sheet metal components and complete it by doing our manufacturing drawings. Okay, so this product, which I told you, the vacuum cleaner. So my colleague Motaz and me, we collaborated on this. We shared ideas. We actually started with a simple sketch, and once we were fine with our sketch and we were fine with the shaping of the product on a sketch, we proceeded to start the design with SolidWorks. So the basic layout of the components related to this vacuum cleaner with the motor, the PCB boards, and the mounting of the components were started first from SolidWorks. Okay, let's see how. Okay, so here your collaboration starts on the 3DEXPERIENCE platform. So in the 3DEXPERIENCE platform, I have a dedicated space for collaborating with my projects, with my files, with my team. And also I can launch SolidWorks from within the platform. So there is no need now to get into the desktop icon and click to open SolidWorks. So as SolidWorks is integrated with the 3DEXPERIENCE platform, you can directly launch SolidWorks from within it. So we had used here SolidWorks as the accessories used for a vacuum cleaner were a native SolidWorks file. So you have a login ID and password. A user login ID and password where you can log in onto your 3DEXPERIENCE platform, and you can have a dedicated space to save your files. And remember, every versioning, revisioning, and every stage of the design, including ownership, is taken care behind the scenes on the 3DEXPERIENCE platform. So as you can see here, I have a sketch, and this helped me to create my layout. Okay, so what we see here is a seamless integration with SolidWorks and the 3DEXPERIENCE platform. Okay, so as you have seen, we have created the concept design, the concept sketches. We have done the layout of the accessories required for the vacuum cleaner, and now it's time to shape our product. As SolidWorks users, using surface modeling was really a tedious task. So most of the SolidWorks users, it was quite difficult to create organic shapes with the conventional surface modeling tools. Now on the 3DEXPERIENCE platform, you have the xShape app on which you can work on your sub-D modeling concept. Let's see how. Okay, first I am going to start by creating my file by clicking the new component for the vacuum design and put it in my collaborative space. Then I am going to insert my SolidWorks design layout from my collaborative space into xShape. This makes it possible as SolidWorks has a seamless integration with the 3DEXPERIENCE platform. The next step will be to create a new component at the origin within xShape. Next, I will be inserting my concept sketches as we usually do with SolidWorks, which will be my reference for shaping my primitive. After inserting the sketch picture, I can change the transparency, adjust, resize, and position the sketch to suit my component layout. This can be done manually or by specifying a distance. 2 sketches for this design are sufficient, the front and the top. In xShape, everything starts with a primitive. From a host of 3D primitives provided within xShape, you can choose the closest of which best suits your design. For this design, I would choose a quad ball to get started with. You can refine your shape by adjusting the number of divisions and dragging the on-screen handles to refine its initial size. xShape will preserve the curvature continuity across the entire shape by eliminating traditional methods required to solve these challenges. Changing the transparency of the primitive will aid in getting a clear view of the sketch. Additional loops can be inserted and deleted to refine your shape and have greater control on shaping your geometry. You can refine your design through a variety of methods, the simplest of which is to select any number of vertices from the shape and then using the on-screen triad to adjust their position. Refining your shape can be done with selecting vertices, edges, loops, and faces individually or in groups. The triad known as the robot helps you move, rotate, and scale in all 3 directions. Powerful tools like symmetry enables you to define and preserve symmetry across the specified plane. This simplifies the design process by allowing you to focus on one half of your model while ensuring that those changes are preserved on the other half. The crease feature aids in creating sharp edges where the percentage of the sharpness can be adjusted. By selecting a group of vertices, you can choose specific tools suggested by xShape to be applied on your selections. After completing your geometry, now you could refine the existing vertices to suit the shape visually. Dragging the entities onto the sketch completes my profile on the portion of the suction mouth. Refining my model helps me to complete the portion on the suction mouth. Now completed the portion of my suction mouth, I would like to refine my geometry on the portion of the handle. Before this, to refine my geometry, I would like to add additional loops and position them in the top view. Just by selecting your vertices and dragging them and using your filters where you can select edges, loops and vertices, you can position them to get a refined geometry. Selecting opposite faces and applying the extrude command removes material from the geometry. Once removing material, now it's time to refine the portion of my handle where I could insert additional loops which gives me greater control to refine the geometry. Having completed this, now it makes it easier for me to shape my vertices to align the shape of the handle and complete my design. Here it is needed to align the bottom vertices as I require to have it aligned to a line. Selecting the bottom vertices and choosing the line align option helps me achieve this. A portion of my handle needs to be stretched where I could select the edge and move it with the triad. So once completed my design, now it's time to save it to the collaborative space. Okay, so what we saw here is xShape is a powerful way of creating complex shapes on a 3DEXPERIENCE platform. So having created my design, I would like to check for surface continuity, draft analysis. Let me check if I have the necessary drafts, and also is my assembly free of interference. So I am going to run an interference detection check. Let's see how it works. So let's start with checking the surface continuity of my geometry. Surface continuity can be analyzed with the zebra stripes feature just like in SolidWorks. Switching between different views by clicking the view cube gives me a clear visual insight on the surfaces. Okay, now it's time for me to check the flat faces on this plastic part. Here it is needed to have a draft of 1 degree. The draft analysis feature similar to SolidWorks enables me in achieving this. Having my draft analysis active identifies faces that have positive and negative draft as well as flat faces. The faces colored yellow requires draft. I start by editing my submodel and dragging the necessary vertices as required. Now my model is free from flat faces. Before running an interference detection on my assembly, I would need to shell my geometry. I will be applying the shell feature from within the xDesign app. Switching between apps is flexible on the 3DEXPERIENCE platform. I click Tools, select the shell feature. As with SolidWorks, I select the faces to be removed and define a wall thickness of 2 mm. And it's done. After my shelling is complete, next I will proceed to check for interferences in the assembly. I will first activate the top level of the assembly and then run the interference detection tool. Selecting bodies of scope and hitting the calculate button shows me the interferences of bodies in the assembly. I see the interferences between the PCB and the body, which is a matter of concern. The edge of the shape requires to be moved. Picking the geometry and selecting the edit part activates the part. Next, again clicking on the face gives me a smooth transition into xShape. Now with the help of the triad, I can move the edge to make it free from interfering with the circuit board. After completing my editing with the shape, I can again run my interference detection by selecting bodies in scope and hitting the calculate button. Now I see the assembly is free from interferences. The interference shown can be ignored as it is to do with the wire. I can apply a temporary section view as we have with SolidWorks to view or visualize the internal components of my assembly. What we saw here is validation tools such as zebra analysis, draft analysis, interference detection are powerful tools on the 3DEXPERIENCE platform, by which you can validate your design prior to manufacturing. 3DEXPERIENCE takes care of the files which were created in their native formats, whether it be xShape or xDesign. To complete my design, I will need to add additional features to the plastic part. So here, I am going to add some bosses to connect the parts. After adding my bosses, I am going to split my bodies using the multi-body technique. Let's see how. So here I am going to split the geometry using the xDesign app. I can reorder features by moving the rollback bar. In this case, it is necessary to add the bosses before the shell. I start by creating the profiles needed for the boss. Making the part translucent helps me to place my sketch profiles in context with the assembly. After completing, I apply the extrude feature to remove material from the geometry. Applying a radius of 2 mm on the edges of the boss completes it. Now, drag the rollback bar to activate the shell feature. Let me now proceed to split the bodies. I have already created a sketch which acts as a trimming tool for the split. Go to Features and select the Split command. Select the bodies to be split. Pick your splitting tool, which is the line, and click OK. Now my body is being split into the left hand version and the right hand version. Let me, in the similar way, split the suction mouth. Select the split body tool, pick both the bodies and pick your cutting line. Say OK, and it's done. Now I will need to combine the left hand side and the right hand side of the suction mouth. So I use the combine option. With the option selected add and click OK. This combines my suction mouth. After creating my body, now it's time to save my bodies as separate parts. So this is being achieved by the make feature component. This feature maintains the link with the parent body. So similar way, I am going to create the component for the right hand part and also for the mouth. Using the isolate command helps me to view individual parts. From this, we see that features can be reordered to achieve design intent. The multi-body technique is a powerful way to complete your design.
Thank you, Rajesh. You did a great job. It's my turn now to complete the design by adding more details. And what I'm going to do is to add this small clamp. And to do that, maybe you are in a lockdown or you are not able to get into your desktop computer to access SOLIDWORKS. So all of your data should be accessible from anywhere. And this is exactly what I'm going to do. I will be using one of the rules inside of 3DEXPERIENCE, which is Sheet Metal Creator rule. And inside this rule, I will find xSheet Metal. Believe me, if you are familiar with sheet metal design, this simple clamp, it's not simple. So let's see how can we use xSheet Metal to design the part. I'm going to use exactly the same assembly that Rajesh did. And from there, I will be inserting my own clamp part. Remember that I'm inside xSheet Metal. So I'm hiding the body just to make sure that I can access my motor. The clamping would be for the motor, and that's why I have to reuse some of the edges from the motor to create my reference plane. And here we go. We are just making a very good design concept by using the top-down assembly concept, creating the plane on the edge and using even the edge, convert to the entities, and then use that resultant circle to create my sketch. I don't need the whole circle, so I will trim the unwanted piece of the circle to keep only the arc. And then I'm always keep my design intent by adding dimensions. So I will add dimension here. And to start with the sheet metal feature, first I have to define my sheet metal parameters. And that's why I'm going to the sheet metal parameters, defining the thickness, the bend region, the K factor, and even the relief type. This is one of the ways to start the sheet metal design in xSheet metal, by the extrusion feature. And here I'm defining in both directions, 2 mm in the right direction, 4 mm in the left direction. And now it's time to create a swept flange. Actually, this is not a normal flange because it can create an edge flange over the circular edge. And of course, I will not be using the same bend radius, the default bend radius. I'm going to change that in the swept flange feature. So how can I keep going with the swept flange? For that, I will be selecting one of the sides of my clamp, and then of course, xSheet metal did a great job by selecting all the tangent edges. Let me repeat that back. First, I will hide the plane just to see the other side of the clamp, and then I will be selecting the swept flange. And again, I can reverse the direction, and here we go. We are done. So one more thing that here I need to add it to my sheet metal part, which is the fillet of the corners. So to corner these corners, I'm using the machine learning inside of all the X apps in the 3DEXPERIENCE platform that enable you to select multiple edges at once. So it looks great, everything is fine, but I still need to show all the components. And before showing all the components, I need to examine the flat pattern. So I can go to the Feature Manager Design tree, or I can select my component, the sheet metal component, and access the flyout toolbar to get the folded state or the flattened pattern of my part. All are done. I need to show the body to make sure that it's not going to be interfere with the other components, as Rajesh showed to us that we can make them some interference detection. But I think all are good here. I'm almost done. We have seen xDesign and xShape before. Now I introduced to you xSheet metal, which give you the capability to do all the sheet metal design on the cloud, collaborating with your team members. We completed almost all of the designs. And remember that all of the design in the 3DEXPERIENCE platform. What we need to do in the next stage is to use SOLIDWORKS to create a drawing. So let's see how. As we are collaborating in the same collaborative space in the 3DEXPERIENCE, if I would like to open that in SOLIDWORKS, again, it's simple drag and drop from 3DEXPERIENCE platform into SOLIDWORKS user interface. And before going to the drawing, I would like first to create a nice exhibited view to show all of the work that have been done, to show the left hand, the right hand, the mouth section, and also the clamp. So the mounting clamp is there. I can see all of them. Very nice view to be represented in the drawing. As usual, I'm using the normal tool to make drawing from assembly to create my drawing, selecting my template. And here we are. First view that I will start with is the exhibited view, drag and drop in SOLIDWORKS, and then changing the scale. And of course, I need to change the state, display state of my view here. And also I would like to add more views like the right view and the top view. So drag and drop will do the job. Let's add some dimensions just to arranging the views and adding dimensions to show the overall dimension of the vacuum cleaner. It's not necessary to show all of the dimension here. I'm just showing you that we can add all the dimensions necessary. But the most important thing is to add the bill of material. That's why I'm using my own template to create the bill of material for all the components represented in that assembly, the vacuum cleaner. And again, very important to add the balloons. So almost done. Final step is to upload all of these nice drawings to all my team members, specifically Rajesh, that he would like to see the final drawings of all of our work. So within the connector capabilities between SOLIDWORKS and the 3DEXPERIENCE platform, it's just about to save everything on the cloud. And we are done. So what we have done so far, we started from a concept design, from creating all of the components initially in SOLIDWORKS that has been stored in the 3DEXPERIENCE platform, bring them all together into SOLIDWORKS. And from there, we have been using xShape. xShape is included in the 3D sculptor rule in the 3DEXPERIENCE platform. And I can call this as advanced surface modeling for us as a SOLIDWORKS users. And from there, we have been able to create the organic shape using the sub-D modeling. And not only that, we have then go to the xDesign, which included the 3D creator rule. And we are able to create the parametric necessary features. Not only that, we have seen also how can we create multi-body inside of the 3DEXPERIENCE platform. And we extended this capability to create some sheet metal features using xSheet metal, which included in the sheet metal creator rule. And then we brought all of them together back into SOLIDWORKS to create the manufacturing drawings. Remember, this is only one concept. It's our concept. With the 3DEXPERIENCE platform, you can create your own concept. And remember also that we were not able to achieve this without two basic rules, which is the collaborative business innovator that enabled me and Rajesh to collaborate together, to communicate through the community, through the conversation, through the chat, and also the collaborative industrial innovator rule. The second rule, which enabled us to securely save all of our designs and also track the versioning and revisioning. So 3DEXPERIENCE platform, it's an amazing platform that give you the scalability to give a lot of freedom in your designs. So the only platform that can connect the sales, marketing, engineering, and production, and all of your departments, all of them together in one single platform. Thank you for joining this session today. And of course, we will be waiting you for your questions.